Okay, I'm Guillermo Diaz-Pulido. I'm a senior lecturer at the Griffith School of Environment.
My name is Bonnie Lewis. I'm a PhD student at Griffith Uni in the Coral Reef Algae Lab. I'm looking at the effects of ocean acidification on the growth of coralline algae.
Well, we're actually testing a fundamental hypothesis here, and is to see whether elevated nutrients coming from nutrient runoff and pollution might actually be useful or might actually help the algae to cope with elevated carbon dioxide concentrations.
So coralline algae play very important roles on the reef. They help to cement the reef together and protect it against cyclones and storms. They provide habitat and food for other creatures to live off.
We're looking at how does climate change, ocean acidification, and warming interacts to modify the growth of these very important algae in the reef.
So because of their very soft calcium carbonate skeleton, coralline algae are a good indicator species for ocean acidification. And the experiment we're running at the moment will help to evaluate the effects that future climate change will have on their growth and their ability to cement and stabilise the reef. We have 3 different CO2 treatments, low, which is ambient levels today, medium and high. We have 2 different nutrient treatments, an ambient and a level that's similar to what's found on the reef during flood plumes, and 2 different light levels, low and a high as well. So the corals were collected at Heron Island and they're brought back to the lab stained with a calcium marker so we can measure their vertical growth and then put in the tanks under the treatment conditions. So the samples were collected about 2 weeks ago, so the experiment's been running since then and will continue to run for another 2 weeks. The response variables we're looking at is the vertical growth. So with the calcium marker we can measure the growth from when they were first put in the treatment until when they're taken out of the treatment. And we're looking at their photosynthetic capabilities from using the PAM and from the oxygen measurements that we're taking.
So the other really exciting aspect of this project is that for the first time we brought different collaborators into a single project. So we have people working from the Australian Reefs Institute here at Griffith University. We have people from the University of Queensland. We have mineralogists from the Australian National University. We're also collaborating with the Great Barrier Reef Foundation, who is funding part of the research that we're currently doing here. So by bringing all these different expertises from different scientific institutions and partners, we're going to be able to have a much better understanding of the potential impacts of global climate change on this very important group of coral reef algae.